Well, today we're gonna do the integral of x power of Ln(x), and of course this is an non-elementary integral. You see x raised to another x is opponent power, and here x raised to the x, the integral of x raised to the x cannot be integrated, even in the non. I don't think x to the x has a function, right? But this can be integrated in a non-elementary way. And let me show you. First, we're gonna use our u sub let u is equal to Ln(x), and then the original just weigh e's on both sides. This is my hobbies. Weigh c on both sides, you get e to u is equal to x. The advantage of this, because you just need to do a derivative on both sides, e to u du is equal to dx. You just get dx. So here, e to the power of u, x is equal to e to the power of u, right? And then you're gonna raise another Ln(x) is equal to u, right? And then you're gonna multiply by e to the u here, and then du. And here, you see e to the power of u, and then u raised to u, you can just multiply by power, you get u squared, and then e to the power of u squared times e to the power of u, you just need to get e to the power of u squared plus u du. Okay, how can we integrate? This is very non-elementary, right? And here, e to the u squared, it reminds us something, right? The integral of e to the power of u squared du. Let me just write a note here. The integral of e to the u du or dx, let me use u here, is equal to square root of pi over 2, and then multiply by the imaginary error function Fi of x plus c. So how can we get that square here? We can just combine this, complete the square. Let me do some checks here. U squared plus u. Let me just add, take a half of it and then square it. Minus 1/2 square. You see, 1/2 times 2 times u just get in the middle, u. So this is just u plus 1/2 square minus the 1/4. Here, 1/4. So u square plus u becomes the integral of e to the power of u plus 1/2 square minus 1/4 du. And let me just bring the e, because e to the power of this minus that, you can write it as e to the power of this and then multiply by e to the power of negative 1/4. And e to the power of negative 1/4 is just a constant, so you can put it outside the integral. And then I can write it as 1 over the cube root of e. And then e power of u plus 1/2 square du. And finally, this integral, if you let another variable w is equal to u plus 1/2, and the dw is just equal to du, right? So we can just write it here. This is equal to square root of pi over 2, and then just multiply by the 4/4 of e, and then ELFI of our, and then u is what? Ln(x), right? So ELFI of Ln(x) plus 1/2 plus c, and that's pretty much it. Square root of pi times ELFI of Ln(x) plus 1/2 over 2 times 4/4 of square root of 4/4 of e. Let me just, it's our calculator. The figure was our constant. You can get square root of pi, square root of, wait, why I can't type the square root? Square root of pi divided by 2 times the 4/4 of E. We see what happened. This is about 0.69. Whoa, 69 this constant. Very, very cool.